Welcome to our look at finding volumes of shapes with cross sections. In this video, we're going to take a look at using cross sections that are shapes of squares, rectangles, triangles, and semicircles. Our focus previously was finding area of two-dimensional shapes, and now we're going to find volume of three-dimensional shapes. Our first technique, however, will rely on using simple two-dimensional shapes and stacking several of them together to form a three-dimensional shape. You can see a picture down low that kind of resembles of something of what we're going to look at here. Obviously, it's not as smooth as something that we're actually trying to work on here, but that's what it kind of looks like. We're stacking semicircles there together to form a building. All right. Volumes of solids with known cross sections. For cross sections of area A of X taken perpendicular to the X axis, we're going to use the top volume formula. A of Y perpendicular to the Y axis, we're going to use this formula here. All right, so it's all about what axis the cross sections are perpendicular to. Before we get into calculus, we got to do some geometry. Okay, so there's four shapes that you really need to know a lot about in order to do this. The four shapes are square, rectangle, semicircle, and triangle. All right. So for square, what do we need to know? We need to know a side length, because the area of a square, if you remember, is just side squared. For rectangle, you need to know the length and the width. Why is that? Because the area of a rectangle is length times width. For a semicircle, we need to know the radius, because the area of a semicircle is pi r squared over 2. And for a triangle, we need to know the base and the height, because the area of a triangle is base times height over 2. Let's take a look at our first problem. Example 1, a triangular base. What's important to know here, the triangular base part means nothing. That's just the bottom of this shape. But that's not what we're actually using to solve this. What we're going to use are squares, semicircles, rectangles, and equilateral triangles. So let's draw this graph here. So we have the first function 1 minus x over 2. So that's intercept of 1, and then down 1, right 2, down 1, right 2. So that first line looks like this. And then the second one is negative 1 plus x over 2. So negative 1, then up 1, right 2, up 1, right 2, up 1, right 2. So our second graph should look like this. Also between x equals 0. So that line there. So you can see where the triangular base comes into play. It's a triangle right here. But on top of that triangle, we're going to stack. What are we going to stack? Squares, semicircles, rectangles, or equilateral triangles. Okay? So the first one says squares perpendicular to the x-axis. So that's going to look like this. Here's one of the squares. All right? That's the bottom of one of the squares. And from that, we're going to build up, I don't know if I can draw this three-dimensionally here. All right? A square. It looks like that. That's one of the squares. Okay, and if you drew another one over here, again, there's another square. But you get the picture. We're going to be building a bunch of these, stacking them next to each other, and making some type of shape. All right, so to find the area of the square, we're going to be using the area equals side squared formula. So what is the length of one side? Well, the length of one side is going to be this function minus this function. So S is going to be the top function, which is 1 minus x over 2, minus the bottom function, which is negative 1 plus x over 2. So that's 1 minus negative 1, which is 2, and then negative x over 2 minus x over 2, which is minus x. So one side is going to be 2 minus x. Okay. So then our volume here is going to be the integral from 0 to 2, because we're moving this back and forth along this line, so 0 to 2, of side squared. And the side is just 2 minus x. So 2 minus x squared dx. Okay, and now our job is to take this integral. So before I take the integral, I'm going to multiply it out. That'd be 4 minus 4x plus x squared. Now we can take the antiderivative. So 4x minus 2x squared plus 1/3 x cubed from 0 to 2. And that would be 8 minus 8 plus 8/3 minus 0. So our answer would be 8/3. All right, now B, the same exact thing, but now not squares, they're going to be semicircles. So off this bottom here, we're going to build a semicircle, right? If I drew another one here, a little semicircle, okay? So what we need for the semicircles, we need the radius. This is the diameter, so this is your diameter. So our radius would be half of that, so 2 minus x over 2. All right, let's write an integral out. So volume would be pi r squared over 2. The pi over 2 can come out in front. The bounds remain the same, and we want our radius squared. So 2 minus x over 2 squared dx, which I can write as pi over 2 integral 0 to 2 of 2 minus x squared over 4 dx, which I can write as pi over 8 integral 0 to 2 of 2 minus x squared dx. And didn't we just do the integral of 0 to 2 minus x squared dx? We sure did. So we know that this is 8/3. So my answer is pi over 8 times 8/3, or pi over 3. For the third one, the cross sections perpendicular to the x-axis are rectangles whose heights are 3. All right, so this one is going to be, area is going to be base times height. So we need the base, which we already have is 2 minus x, and the height, which we know is 3. So our volume here is going to be 3 times the integral from 0 to 2 of 2 minus x dx. So that'd be 3 times 2x minus 1/2 x squared from 0 to 2. 3 times 4 minus 2 minus 0, which is 6. And finally, we equilateral triangles. So for equilateral triangles, we need to know the length of one side. We already have that. It's right there, 2 minus x. So the equilateral triangle formula that we should remember, hopefully from geometry, is root 3 over 4 times s squared. So our volume here is going to be root 3 over 4 times s squared dx. And once again, we already know this. We already know that answer. It's 8/3. So it's root 3 over 4 times 8/3. Simplifying that, we get 2 root 3 over 3. All right, now we have a circular base. So let's draw this. It has a center at the origin and a radius of 2. All right, so the cross section is perpendicular to the x-axis again for all these. So once again, this is our base, and the cross section is going to be perpendicular to the x-axis. And we're going to build that up from there. So if the equation of this circle is x squared plus y squared equals 4, if we solve that for y, we get y equals plus or minus root 4 minus x squared. The top half would be 4 minus x squared. The bottom half would be negative root 4 minus x squared. So from here to here would be this minus this. All right, so one side for part A here would be root 4 minus x squared minus negative root 4 minus x squared. Or in other words, 2 root 4 minus x squared would be the length of one side. All right, so our first volume here, squares, so side squared. So that side squared. So first of all, our bounds are going to run from -2 to 2. So -2 to 2 of side squared dx. So this would be -2 to 2 of 4 times 4 minus x squared dx, if you square everything in there. Now what you could do is you could distribute the 4 if you want, or you could just bring the 4 out in front. That might be easier to do. And we're left with this. Okay, now integrating, so 4 times 4x minus 1/3 x cubed from -2 to 2. And that's 4 times 8 minus 8/3 minus -8 plus 8/3, which is 4 times 16 minus 16/3. All right, and that would give us 64 minus 64/3. Okay, getting a common denominator there should give you 128 over 3. Because this would be 192 over 3 minus 64 over 3, 128 over 3. All right, question B. Now there's semicircles, so pi r squared over 2, right? Pi r squared over 2. So what is r? R would be half of this. So r is just root 4 minus x squared. So volume is pi over 2 r squared dx. Or just pi over 2 times the integral of 4 minus x squared dx from -2 to 2, which we already know that answer would have been, okay, if you just divide this by 4, be 32 over 3. So our answer here is just going to be pi over 2 times 32 over 3. Which is 16 pi over 3. Okay, if you're not really sure how I got that part, basically, this is your integral right here. 16 minus 16/3. So 48/3 minus 16/3, which is 32/3. That's this integral. Part C, cross sections perpendicular to the x-axis are equilateral triangles. So that would be, this is one side, right? So it's going to be root 3 over 4 side squared. So integral of 2 root 4 minus x squared squared dx. And we already did this integral. This integral was all of a right there. So the answer is 128 over 3 times this number right here. So root 3 over 4 times 128 over 3. Basically just dividing 128 over 4, you would get 32 root 3 over 3. part D, the hypotenuse is 2 root 4 minus x squared. So if you think of this would be a 45, 45, 90 triangle. I'm not going to get into the whole details of doing the 45, 45, 90 triangle, but basically in a 45, 45, 90 triangle, the height would be half of the hypotenuse, okay, because of the 45, 45, 90 properties that you would work with through there. So to get the area of the triangle, we just do base times height over 2, right? So the over 2 part can come out in front. The base is the whole S that we found earlier, and the height is half that. So if I bring this 2 out in front and multiply the other 2 together, I would get the integral from -2 to 2 of 4 minus x squared dx, which we already found earlier was 32/3. And last one, cross sections perpendicular to the x-axis are isosceles right triangles with a leg residing in the base. So the leg is the base, and the leg is also the height. So basically, our volume here is going to be 1/2 times the integral of -2 to 2, base times height, and the base and the height are going to be the same s that we found earlier. If we bring both those 2's out in front, we're left with 2 integral of 4 minus x squared dx, which we already know that integral was 32/3, so 2 times 32/3 is 64/3. So this is just a summary chart of everything that we've been talking about here so far. The different type of shapes, what we need to know, the geometric area formulas, and then the volume formula for finding them. I don't expect you to memorize this. I just want you really to think your way through the problems and go from there. All right, example 3. All right, we're going to do the last couple here using our calculators as well, just setting up and then using our calculators to solve. All right, so hopefully you have a calculator handy. Find the volume of the solid whose base bounded by those curves shown with cross sections perpendicular to the x-axis that are semicircles. So perpendicular to the x-axis, semicircles coming out of them. Okay? So we need for the semicircle to be pi over 2 r squared. So it'd be pi over 2. The radius would be half of this height there. Okay, so it'd be 8 minus x squared over 2. That would be our radius. Clean that up a little bit. We get pi over 2 times 8 minus 2x squared over 2. If you divide both those by 2 in there, we get pi over 2 times 4 minus x squared. Okay, so the bounds here are going to go from -2 to +2. So our volume is going to be pi over 2 integral from -2 to 2, 4 minus x squared dx. All right, let's just do this integral in our calculator here. So this would be integral from -2 to 2 of 4 minus x squared dx. And that would be 32/3. So pi over 2 times 32/3 would be 16 pi over 3. Example 4, volume of a solid whose base bounded by the curves shown there. Cross section is perpendicular to the x-axis. Semicircles again. So semicircles, pi over 2 r squared. The radius would be half of that. So root x minus 0 over 2. So in other words, it's going to be pi over 2 times root x squared, which is x over 4. In other words, pi over 8 times x. And I just realized on this last one, I'm very sorry, I forgot to square this. So this has to be squared. So this has to be squared. So this has to be squared. So let's go back and redo this one in our calculator here. Hopefully you caught that and are yelling at the screen at me right now. So now our integral would be 512 over 15 times pi over 2 would be 256. So 256 pi over 15 would be our balance there, our integral, our volume. So back to this one. Sorry about that. So we have pi over 2 r squared. So pi over 2 times the radius, which would be pi root x minus 0, because this would be root x minus 0, over 2. And that would be root x squared over 2 squared, so x over 4. And simplifying that, we get pi over 8x. All right, so now our volume would be pi over 8 times the integral from 0 to 9. I know it's 9 because it tells us right there, of x dx. All right, and this is a pretty easy one we can do without a calculator, but we're going to try it with our calculator anyway, just to make sure we remember how to do this with our calculator. And our answer would be pi over 8 times 40.5. And if we convert that into a mixed fraction there, an improper fraction, so it would be 81 pi over 16. Okay, number 5, it's the same problem. It's the same problem, except now we're perpendicular to the y-axis, and we're doing squares. So y-axis, and we're going to be doing squares. So our side here, well, first of all, our area would just be side squared, and our side would be this minus this. Okay, this line, which is x equals 9, minus this shape, but it has to be in terms of x. So x equals y squared. So our side is going to be y squared minus 9. So our area is y squared minus 9 squared. So then our volume is going to be the integral from 0, so 0 to this number here, which is 3, the square root of 9, which is 3, of y squared minus 9 squared, dy. All right, so in our calculator, 0 to 3 of, you can just use x squared minus 9 squared dx in your calculator, and we should be getting 129.6 or 648 over 5. All right, last one. This is some extra practice. It's the same thing we did before. It's a circle perpendicular to the x-axis. I would encourage you at this point to stop this video, try this problem on your own. Try these 4 on your own here. A little help on D. So our area is base times height, and the height is 2b, so b times 2b, or 2b squared. All right. Once you've tried all these problems on your own, check the note key posted, and you can see if you got all 4 of those right. All right. But that's going to be it for this video on topics 8.7 and 8.8. Thanks very much for checking out the video today.